So hi everyone, I welcome you all to this fifth lecture on fluid mechanics. So today we will be continuing our discussion on pathline, streamlines, and streaklines, and we will be looking at some examples and we'll derive some like the governing equations to get the streamline, pathline, and streakline, and we'll look at some examples accordingly. Okay, so let's start with the streamline. So because it is the easiest concept. So as we have discussed that streamline is used to
Can you
uh,
make it can you make it full screen?
okay.
Yes. Thank you.
So yeah, so a streamline, the concept of a streamline is basically used to describe the oily the used to describe the Eulerian description of fluid flow. And so basically, I will formally define what a streamline is. I already defined once previously. So a streamline is a curve that is everywhere tangent to the instantaneous local velocity profile. So for example, let's say the velocity vector is given by at any instant. So let's say this is my streamline. At an instant, my velocity vector is, so my velocity vector is this. Then locally, this streamline should be parallel to this velocity vector. So if it is the velocity vector, then this streamline should be parallel to this. So basically, it's not it is tangent to this. So this is my streamline. Let's say dr, and here let's say if it's a streamline, it's so here's the velocity vector, and streamline is tangent to the velocity vector. Okay. So for example, to look at the governing equation to get the streamlines, let's assume that v is vx I cap plus vy j cap plus vz k cap, and dr is the describing the position at which we are going to find out the streamline. So that is dx I cap plus dy j cap plus dz k cap. So both of these are tangent to each other, which means that both are parallel to each other, and therefore v cross dr should be equals to 0. So this is the equation which is governing the streamline. Okay. So So to get the equation, we have V.
Can you explain the difference between blue line and magenta line and black line? I didn't get it. What is blue line?
So blue line is uh, dark blue you are asking, or the this blue line?
Blue line. हाँ ये वाला.
This one, this one.
Yes.
So it is some streamline over the flow. Like we wanted to get the equation of this streamline, which is uh, in the flow. There is a streamline in the flow. So basically, this path is basically the curve which is locally parallel to the instantaneous velocity vector. So for example, uh, I can I can say it conversely in a way that, let's say I am having a velocity vector changing instantaneously with position like this, uh, like this.
Is it the path followed by fluid?
Yeah, it is the path followed by fluid. So this is, for example, this is the velocity vector at different instant, at different instant of time and with position. So this is the velocity vector. Okay. So if I have to draw the streamline, then it should be locally tangent to this velocity vector and this velocity vector, then this
So
velocity vector.
streamline is nothing but a locus of streamline is basically path followed by fluid, and at each point, what is
So
the
this,
velocity?
this line is basically, my magenta line is the streamline, which is locally, which you see, which is locally parallel to the instantaneous velocity vector. That is what is a streamline.
Parallel.
What?
It is not parallel. It is
Yeah,
touching.
it
No.
is locally parallel. It is locally parallel. So it is
So,
basically, it is the tangent. So it is the tangent to this, no?
so
So
tangent means there is a common point between two curves, right? That means they are intersecting line or touching line, not parallel line.
no, no, tangent in a way that tangent means what I can say, how can I say? So let's say this is my streamline. So then if I have to, this is streamline is coming because my velocity vector at different instant are like this, which is locally, which is a local tangents. So this profile is the tangent to this. So it is to the local velocity profile. So it's not a velocity profile, it is local velocity. So local velocity vector का जो tangent होगा.
What is the
So
physical significance of streamline?
basically physical significance, the streamline is used to describe the fluid flow. So let's say if you want to describe, like you want to see, like for example, you are having a fluid is flowing like this in a channel, in a pipe flow. So you may want to get the velocity to get the profile to see how the velocity is evolving. You will try to draw the streamline, and streamline, you may want to draw the streamline to get the profile of the, so the streamline, so these are the streamlines which is there in a laminar flow. So so the physical significance is just when you are describing the fluid flow using a Eulerian description, then you wanted to know, like how the flow, like what is the behavior of the fluid. So how the velocity is changing instantaneously with the location. So if you draw the streamlines, you will know that the velocity is changing like according to that.
Okay, sir. Thank you.
So, so I wanted to know the equation of the streamline, and so what I said is it is a tangent, which means both are uh, parallel to each other, such that V and D are cross product of these should be equals to 0. So we using this we can get the equation of the streamline. So uh, we know cross product is nothing but uh, I cap, j cap, k cap. Determinant of this matrix should be equals to 0. Vx, Vy, Vz, and dx, dy, dz. Okay. So let me solve this determinant. So I cap means Vy into dz minus Vz into dy minus j cap Vx into dz minus Vz into
And
dx.
dx, dy, dz are operator, or they stand for some numeric value?
But this is not a operator. These are like operator. If it is an operator, then you can just write d now. D is operating on something. It is uh the small elements dx, dy, dz
Okay, thank you.
plus k cap Vx into dy minus Vy into dx is equals to 0. So one minute, I'm getting one important. So so to have this equation to be 0, we want individual component in all these directions should be equals to 0, which means that Vy dz by Vz is equals to dy by Vy. From here we can get dz by Vz is equals to dx by Vx, and from here we can get dy by Vy is equals to dx by Vx. So the equation for the streamline becomes dx by Vx is equals to dy by Vy is equals to dz by Vz. In two-dimensional, dz will not be there, so dx by Vx is should be equals to dy by Vy. ठीक है? An important point to note that is streamline can change as a function of time. Okay, so this is about. So let me take the example of. So let me take the example of streamline. So the question is, Find out the streamline equation passing through the point 5 comma 10 for a given velocity profile. Also check if the if the flow is steady or not. Okay, the flow field is given as the flow field is given as V is equals to A1 x I cap minus A1 y j cap, where A1 is given to be 0.5 second inverse and x and y are in meter. So to solve this question, so let's solve this question because we know what V is. So V is A1 x I cap minus A1 y j cap. So which means Vx is nothing but A1x and Vy is nothing but minus A1y. Okay. So we wanted to find out the e equation of the streamline. So this equation of the streamline we know for the case of 2D is nothing but dx by vx is equals to dy by vy. We'll substitute this into the equation. What we get is dx by vx, that is a1x, is equals to dy by minus a1y. Okay. So now we wanted to know the equation in terms of x and y, so we can just directly integrate this equation. So upon integration, what we get is, so a1 will not be there, ln ln x should be equals to minus ln y and plus ln c1, which is the constant of integration.
Sir, are dx dy operator or they are number? Earlier you said those are numbers.
No, these are not operator. This is just a small element dx. Operator is different thing. It is
Acha,
not operator.
okay.
So what we get is x ln x plus ln y is equals to ln c1. So x y is equals to c1. Okay. So this is the equation of the streamline. Now we wanted to know the equation of the streamline passing through this point, that is 5 comma 10. So we'll just put 5 comma 10 in the equation and we'll get the value of c1, which means that x is my 5 into y is 10 is equals to c1, which implies that c1 is equals to 50. So the equation of streamline passing through 5 comma 10 is x, y is equals to 50. So this is the answer. Let's understand the notion of what is path line. So path line is fundamentally defined as it is defined as the trajectory of the fluid particle over some time period. So for example, if the fluid is flowing uh, in this channel, so let's say you put a tracer particle here and it follows some path like this, or in any another disturbing flow where it may follow this path. So uh, path line is the trajectory of this particle followed over some time. From, let's say it is at t naught here and it will reach to t naught. So at some time, after some time t, it will be here. Okay. So the equation describing the path line is given as x is equals to x naught plus t naught to t vox into dt. Similarly, in terms of y, it is y is equals to y naught plus t naught to t vy into dt. So these are the equation for the path line, and in the application. So if you wanted to use the Lagrange description of the fluid flow and you wanted to know the how uh, what is the behavior of the fluid, and you want to analyze the fluid, then you will put a tracer particle and you are tracing that particle, like the path it is following, that particle is following. So that is these are the equations for path line. And to discuss the example, okay, so the question is find out the equation. And these equations are just coming from like this here, d, so the velocity of the particle you are tracking, vp x is equals to dx by dt, and vpy is equals to dy by dt. So these are the particle velocity, which depends on the initial position of the particle, and these equations are coming from here. So now we have to find out, the question is we have to find out the equation of path line. Path line of a particle initially at the position 2 comma 8 the velocity field is given in the previous question. Okay, so now we so the particle will also the same follow the same flow field, so the particle velocity can be taken as dx by dt, because we are now following the particular particle. Okay, so vpx is a1x and vpy is minus a1y, and at t is equals to 0, these particles are at x is equals to x naught and y is equals to y naught, and here x naught and y naught are 2 comma 8. So dx by dt is a1x. So x, we just have to integrate this equation. Dx by a1x is equals to dt. So ln x is equals to a1t plus c1. Maybe I can ln c1. So ln of x by c1. So x will become c1 e to the power a1 into t. Okay, and at t is equals to 0, x is equals to x naught, which means my c1 becomes x naught. Therefore, the equation in terms of x coordinate is x is equals to
Hello, sir, we cannot hear you.
so there was some internet connection issue.
Now we can hear you.
Yeah. So are you able to follow till this part?
Yes, but recording stopped. Start. Okay.
Okay. So dy by minus a1y is equals to dt. So ln y is equals to minus a1t plus ln c2. So y becomes c2 e to the power minus a1t, and we know y is equals to y naught at t is equals to 0. Therefore, c2, it implies that c2 becomes y naught, which means y is equals to y naught e to the power minus a1 t. Okay, so this is the equation for y, and to get the trajectory of the path line for a particular particle which is going through x naught and y naught, we need to substitute t in from one of the equation. So what we do is we'll multiply equation 1 and 2, and therefore what we get is x y is equals to x naught y naught. So this is the equation of path line, which is of the particle which is starting from the position that is x naught and y naught. Now we can get x naught y naught because we know what is x naught y naught. So x naught is 2 and y naught is 8. So the equation of the particle whose initial location is, so the equation of a path line whose initial location is given by 2 comma 8, equation of path line of a particle is given by x y is equals to 16. So the particle, if I have to plot this path line x in terms of y comma x, so if it is, let's say, starting from the position 2 comma 8, so x is 2, let's say x is 2 and y is 8, it is starting from this position. So I think the path line it follow after, so it's like looks like a corner flow. So this is the equation of the path line followed by this particle. Okay. Now I think path line is clear. Is there any doubt in the path line and the streamline? Path line is used to describe the Lagrange flow through a Lagrangian description. And yeah,
No,
any
sir.
any
No, sir.
doubt?
No.
Mrityunjay, any doubt?
No, sir.
ठीक है. So let's finally discuss the streak line. It is bit uh it is bit difficult to understand, but we'll try to understand it. So in a streak line, first I will be giving example. So let's say you are having a chimney and there is a smoke coming out of it. Okay. So maybe I can, using black, I can make smoke. Some smoke is coming out of it. So you have injected one particle here at t is equals to 0. After some time t, this particle will go so after some time t, this particle may go here, and we are injecting another particle here. Okay. Now again after some time t, we again inject another particle. So now what happens? This blue particle will go elsewhere, and this pink particle also will go elsewhere. So maybe this blue particle is following some path line like this, and it will go after some time t. So t is equals to t naught here. After some time t, it will go there, and then this will this pink particle at this time instant will follow another path line, maybe like this. Okay, and at the same time we are injecting another particle here. So maybe this is t1, t2. After some time t, this is following this path line, this is following this path line. We'll check the path line followed by the orange particle. So let's say this particle goes there, this particle goes there, and this particle maybe goes here, and this particle, this orange particle, will follow this path line and goes there. So what streak line is? So we are keep injecting the particle at different time instants, and these particles are following their own path line dependent on the flow. So the streak line is something that connects all of these particles. And at t is equals to t3, we have injected another particle. So if you make a if you connect all of these particles at particular time t, so if I connect this, so basically this line is my streak line. So we are keep injecting the particle, and each particle is following their own path line. At some time instant t, we wanted to know the streak line. So to know the streak line, we should get the position of the those individual particles at that time instant, and we should connect the position of those particles, and we will get the streak line. So this is what streak line is. So basically, in terms of language, I can write this is nothing but the locus of fluid particles at particular time. Streak lines is the locus, or more precisely, I can write that streak line is the locus of the fluid particle passing sequentially. So a streak line is the locus of the fluid particle passing sequentially. So we are tracking the particle sequentially, one by one we are keep injecting, and we are tracking the particle sequentially through a prescribed point in the flow. Okay, so this is what is a streak line, and the equation of the streak line is given by x is the position of the injection plus Vx dt, time of injection, to some present time. Okay, so a streak line, so it has the information from where we are injecting and the path, the like we are joining this to the position of the particle, which is at some time from injection to some time t there, and it will follow some path which is called to be as a streak line. So maybe we'll discuss one example for a streak line. So we are given a velocity field that is x by t I cap plus y j cap. Find out the equation of a streak line for a particle which have passed for the particles which have passed through some which has passed through x naught comma y naught over a period of time from t is equals to from some t prime is equals to t naught to t prime is equals to t. Okay, so again that is straightforward. So first we get the equation of the path line. So the equation of the path line we can get of a particle passing through x naught y naught, that is Vx is equals to x by t, Vy is equals to y. So dx by dt is equals to x by t, and ln x is equals to ln t plus ln c. So x is equals to c t. Similarly, dy by dt is equals to y. Ln y is equals to t plus ln c. So y is equals to c e to the power, you can take c prime a to the power t. Now we know this is has to pass through x naught y naught at some time instant t prime. So x naught is equals to c t prime, y naught is equals to c prime e to the power t prime. So c we know x naught by t prime, and c prime uh, is y naught a to the power minus t prime. So what we get is x is equals to x naught t by t prime, and y is equals to y naught e to the power t minus t prime. Okay, so these are the path lines. Now we need to eliminate this t prime term to get the equation of the streak line. So from here it is easy to substitute. So t prime is x naught t by x. So y is equals to y naught a to the power t minus x naught t by x. So this is the equation of the streak line which is passing through the position x naught y naught at t is equals some time t is equals to t naught, and some later time t. What will be the equation of the streak line is this. Okay, so all of these are the examples of the. So I hope now pathline, streamline, and streakline are very clearly discussed. In the next lecture, we should discuss the control system, control volume, the notion of the control mass, and the equation of the continuity, and will derive. I will try to catch up it, but because of the time, I'm unable to do it this now. So, but in the next lecture, we'll discuss it, and we'll discuss in detail like what is steady state and what is not. So I think कोई doubt है तो बताओ यहाँ पे. We can discuss it, otherwise we'll go and
No, sir.
Mrityunjay. Mrityunjay, कोई doubt?
No, sir.
No, sir.
Okay. ठीक है, then we'll meet next Friday. Thank you.
Thank you.